Hello everyone. In this video, we will be covering three topics. First is what is function. Second, we'll be doing some examples and finding the range and domains for a function. Third will be vertical line test for a function. Let's start with the first topic. What is a function? What comes to your mind when you think of a function? Let's see what is a function. Function is a kind of machine in which you put a variable x and you get an output f of x or y. This is a machine. Another way to represent a machine is, or a function is, by an arrow diagram. This is point A, this is point B, this is point C, this is point E, and here this is f of A, this is function of B, similarly function of C. As we can see, each individual value from this set of real numbers D represent a unique value in this set of real numbers E. So this is the basic rule of a function. Each value has, this is a independent variable and this is a dependent variable. So this is the input and this is the output. A basic definition of function is when the second or this set of values E, the second variable or second number is the function of first number. For example, f of x equals to x plus 3. Now, the value of f of x, this dependent variable f of x, depends on x plus 3, this variable. And x plus 3, or we can say x, is this set of values D. And f of x is E, because these are dependent on D. And D, set of values D, are independent. So here, let's see what the graphical representation of this function is. So f of x equals to x plus 3, right? Let's draw the graph of this function. Sorry, my drawing is not very good. Here we go. So this function has y-intercept as 3 and the x-intercept is -3. So it will go like this, right? This is the graphical representation of this function. So here we see that the value y depends on this x-axis. Interesting, right? And the value of x can be from -infinity to +infinity. as we can see, the function is defined for all the values from minus x minus infinity to positive infinity. So this brings us to our second topic, range and domain, the second topic of this video. So here, as the word range says, the varying y values, right? Range. And the domain is the input, which is on the x-axis. So for this function, as this function is defined at all the values on the x-axis, the domain is from negative infinity to positive infinity, right? And the range is similar to domain, negative to positive. So this was a basic example of what is a function. Let's do some complex. So here, x plus 4, right? Or we can write function of x equals to 4. So here we know this value cannot be equal to, cannot be less than or 0, right? This value cannot be less than 0. If this value is less than 0, then this function is not defined. So if x plus 4 is greater than equal to 0, then x is greater than equal to minus 4. Simple as that. X cannot be minus 5, because if x is minus 5, then minus 5 times 4 gives us minus 1 under root. This is not defined. So here the range and domain will be tricky. I want you guys to pause the video and think about these two values for this function. So let's see what is the domain first. As we can see, this machine or this function can take values greater than minus 4, greater than or equal to minus 4. So here, and close brackets, minus 4 to infinity, open intervals, right? And the range will be the least value this function can go is 0. It cannot go negative. So the value here is 0 to infinity, right? So these are the range and domain topics we covered, 2 examples. Let's quickly do one example to see to find the graphical representation of range and domains. Assume an equation y equals to 4x plus 3. Here the y-intercept is 3 and the x-intercept is here, somewhere here. So let's draw a line, right? 3. So here, so when x is equals to 1, y is equals to 7, right? Just put x in here, 1 here, and then y gets 7. So 1 equals to 7. Just assume this point is 7, right? And at 2, x equals to 2, y equals to 11. This point 11. And when x equals to 0, y equals to 3. This point here, 3. So here These are the f of x's. So this is f of 2, which gives us 11. Similarly, this is f of 1, which gives us 7. And similarly, this length is f of 0, which gives us 3. So we can see how easy it is to represent by a graphical representation. But remember, if for some reasons this graph was cut short at till positive value of x only, then the range will be from 3 up to infinity. For example, if I had this similar graph, but in this case we are not going to the negative x's, right? We are not going considering negative values of x. So here the range of the whole function will be from 3 till positive infinity, because here we saw the graph intersects at the minimum positive value, that is 0 or greater than 0, at 3. So the range will be from 3 till positive infinity, and domain will be 0 to positive infinity. Now let's cover our third topic and last topic of this video, vertical line test. Now a graph or a curve is a function when each point, like say this is a random function, each point here a, b has one and only unique value, has only one and a unique value, f of a, f of b. See, this is a vertical line, has only one value, 1 in here. But there are some cases where say something like this, right? Here this point f of a have two values, 1 and 2. This is not a graph of a function. This is a function, but this is not a function. Another example is, one more example of a graph, and you guys tell me in the comment section if this is a function, graph of function or not. X equals to y squared minus 2. Let's draw the graph of this function. This is 0, minus 2 comma 0, and you tell if this is a function or not. Tell in the comment section. I'll check the answers in the next video and explain this graph. I hope you guys understand all the topics we covered in this video. That's it for today. Thank you for watching. Take care.